Hi, this is Marcus Simpson. I'm at Xaar's HQ today for FuturePrintTV. We're here today for the R&D Open Day called Seeing is Believing. It's all about ultra-high viscosity inkjet. It's really exciting new possibilities for this technology. It's a big showcase. The first time they've had an open day, and FuturePrintTV is here to capture it. So looking forward to learning, and seeing is believing.
So viscosity is thickness. How thick is the fluid? And viscosity is usually measured with units called centipoise. And to put into context, water is 1 centipoise, and something like honey is probably 5 to 10,000 centipoise. And if you look at the digital inkjet technologies that are available in the market at the moment, they range from being able to jet something like 5 centipoise to something like 40 centipoise. So it's a fairly small range. But actually, a lot of those printheads can only go up to something like 10, maybe 12 centipoise. And what that means is that that really limits the formulation of the fluid that you can put through those printheads. That means that the chemists are fairly constrained with the functionality they can put in those inks. And that means that those inks contain quite a lot of water for water-based printing, which means that if you look at water-based printing machines, they usually have an enormous dryer at the end of them, which takes a lot of energy to run. With our technology, you can jet 100 centipoise, and that's a real game changer. That really shifts what people can put in the inks. That really shifts how much energy you need to dry those water-based prints that you've just made.
The real opportunities for inkjet with ultra-high viscosity are kind of theoretical and completely unarguable from a theoretical point of view. The challenge has always been, can you actually see it? Can you actually do it? Because if you can do it, then that's great. But in a sense, it's been an existence proof or a commercial reality proof that people have been waiting for. The concept that if you put less water in something, there's less water to evaporate. I mean, that's undeniable.
When I started this work, I was kind of looking at screen printing, flexo, and then I'd come back to revisit inkjet after a few years and not really looking at it. And I've seen quite a step change in terms of the capabilities, in terms of how much ink you can put down, and the colour vibrancy and things like that. So it's very interesting.
So we've been involved with Xaar for a while now, looking at this. And I think what we're really seeing is that, as they said earlier on today, that it opens up this toolbox, that it allows us to do things that isn't the same as we've always done. And that allows us to bring inkjet into a lot of other areas that potentially it's struggled to get into. We've seen some of the examples here where on corrugate, for example, traditional inkjet has struggled, special uncoated, whereas here it's given them a little bit more of a buffer to be able to do what they want at a print quality that they're after.
We could double the speed. And if you double the speed, your production costs will at least half, because the machine costs are decreasing dramatically. But there are some other benefits, I would say, especially for the process. For example, for the glass or for industrial printing, you have always pinning between all the colors, because for low viscosity inks, you had to fix the drop. You had to fix the drop on the substrate that it doesn't level or wet, which at least we get rid of it. Because with this new technology, the pinning is not necessary anymore.
It does not bleed on glass or on different surface energies in general. So there's always the sweet spot to find of surface tension and surface energy of the surface of the article you print on. And with this ink, due to the increased viscosity, it lays much sharper on the glass or on the metal can or on plastic or whatever. I tried it on many substrates.
So when you look at inkjet printing, then typically the range of fluids that you can jet is quite limited. So we mean that we can only jet very thin fluids, right? And really what we're showing here today is that we have developed a technique whereby we can print actually higher viscosity, so thicker fluids. So on the one hand, we have really the core of the print, that's what we call the actuator. So that's a very efficient actuator. separator, which you need to be able to go to higher viscosities ultimately. Then we have our Xaar TF technology. So that's really recirculation of ink through the printhead. Now that's not only a massive advantage when it comes to reliability of printing, but it also helps or prevents starvation of the printhead, which you would traditionally see when printing high viscosity fluids at high frequencies. Okay, and lastly, it's the way we drive our printheads. That's something that we call waveforms. So really the recipe we use to move the walls. So we have optimized that to be able to jet these thicker fluids.
We can actually start moving away from the traditional print sectors and get into many different and varied sectors. So I think particularly when we start looking at 3D, when we start looking at electronics, and when we start looking at fashion and apparel, these markets are governed by the way things are produced.